Assalamualaikum warahmatullahi wabarakatuh. In this opportunity, I would like to present a paper entitled Synthesis of Silica-Cellulose Aerogel, derived from Bagasse, Impregnation, and Ambient Pressure Drying Method as Thermal Insulator by Dr. Ing Silviana, Afrizani Matu Saadah, Rois Pradinadia Astuti, Nadia Hairunisa Ramadhani, Naomi Simarmata, Lim Eriko Arianto, Maureen Yudit Yurma, Jessica Rahmaningrum, Fadl Rahman Fauzi, and Marta Aditya Saleh Mahmud. This is the outline from our presentation. First, introduction. Second, thermal insulator. Third, cellulose aerogel. Fourth, silica aerogel. Fifth, impregnation. And last, conclusion. Thermal insulator has the function to reduce excessive energy loss due to heat and transfer energy from a system to its surrounding environment. The material commonly used in thermal insulator are polyester, glass wool, ceramic, asbestos, polypropylene, and styrofoam. Thermal insulation manufacturing involving polyester is undesirable for the environmental as it's sourced from petroleum. As we know that Indonesia petroleum reserves over the past 10 years have seen notable decrease from 8.2 billion barrel in 2008 down to around 7.5 billion barrel in 2018. Therefore, we need a solution in the form of more environmentally friendly thermal insulator, either by using sustainable material that can be renewed. One of sustainable material that can be defined as the main material used in the manufacture of thermal insulator, such as cellulose. The presence of cellulose fiber in the nature is very evident. In addition, cellulose possesses many advantageous properties over petroleum-based polymer, such as biocompatibility, biodegradability, thermal stability, chemical stability, and of course, low cost. Another material that can be used to produce thermal insulator is silica. Silica has superior transparency and it's resistant to high temperature. This paper recommends the method of impregnation of silica into cellulose to produce the best thermal insulator. Most of the material used to make thermal insulator has many disadvantages, such as ceramic can cause flashover, asbestos can produce fly ash, polypropylene non-biodegradable, and styrofoam produce a lot of waste and difficult to decompose. Renewable material for thermal insulator such as cellulose can reduce energy consumption and the impact of environmental pollution. Aerogel-based cellulose material insulation has a good heat transfer properties. Aerogel as thermal insulator has nanoparticles that are bound to form chains and stable three-dimensional structure. Based on previous research, the best result in the use of cellulose-based aerogel as thermal insulator has lowest thermal conductivity of 18 milliwatt per meter Kelvin. Cellulose aerogel is as a nanoporous solid foam by the replacement of the liquid pass in the gel by the gas pass. Cellulose can be extracted from a variety of different sources, such as wood, cotton stalk, Severus alga, static culture of Acetobacillus and other bacteria, cassava dregs, bamboo, and sago waste. Cellulose can be also extracted from bagasse, in which it can produce 22 until 44% relatively pure cellulose. The advantages of using cellulose for the manufacture of aerogel are, first, the rest of cellulose are renewable. Second, the cellulose chain is rich in hydroxyl groups. It means that no cross-linking agent is needed within the aerogel making process. Third, the stable three-dimensional network structure can be obtained by intramolecular and intermolecular physics cross-linking, thus making the aerogel manufacture process quite simple. Fourth, chemical modification to improve the mechanical strength and structural characteristic of cellulose aerogel is relatively easy to perform. Cellulose aerogel is being applied in many applications, such as absorption and separation material, carbon aerogel precursor, all-water absorption and separation material, biomedical application, gas filter, acoustic insulation, and also thermal insulation. Cellulose aerogel is made in 3 stages. First, dissolving cellulose. Second, forming a cellulose gel. And third, drying the cellulose gel by maintaining porous structure.
The aerogel cellulose synthesis method has several shortcomings from previous researches, namely the density of cellulose aerogel produced is smaller, long processing time, asymmetric aerogel porosity, and low transmittance rate. So, how to improve? First, modify its physical and chemical properties. The physical modification includes the strategy of introducing various inorganic particles such as morilonate, etc., into cellulose-based framework to strengthen the mechanical properties of the aerogel. However, due to the incompatibility between inorganic particles and cellulose, the aerogel aggregation and structure are damaged because of the incompatibility between inorganic particles and cellulose, resulting in aerogel aggregation. Chemical modification is needed by adding a cross-linking agent. Example of the most commonly used cross-linking agents can be seen in the screen. Of the various types of cross-linking agents available, borate cross-linking agent can be selected in the manufacturer for thermal insulator based on cellulose aerogel and silica aerogel from Bagasse. Because borate will increase the compression strength and squeezability of the aerogel, the flammability of the aerogel will also decrease, heat resistance will also increase, then it is not flammable, so it is suitable for insulators. So, what is silica aerogel? Silica aerogel is an aerogel composed by silica and can be made through various types of precursors and plays an important role in the formation of material on a nanoscale. The characteristic of silica aerogel can be seen that it has low density, low thermal conductivity, low reactivity, transparent, and low surface area. The application of silica aerogel is very diverse. First, it can be used as thermal insulator, catalytic support, absorbent, drug delivery, radioluminescence, inertial confinement, fusion, and radiation detector. Of the various types, silica can be extracted from a variety of different material sources. When compared from existing sources of silica material, Bagasse waste can be used as an alternative material for making silica aerogel. The synthesis process of silica aerogel can be includes three steps. First, silica gel is obtained by the sol gel process. The second is an aging process to strengthen the gel, and the third is a drying process. The drying process can be divided into several types, namely the supercritical drying method can be divided into two: high temperature supercritical drying and low temperature supercritical drying. And the last is the ambient pressure drying method and the freezing drying method. Many silica aerogel are made using the ambient ambient pressure drying process. These are types of precursor in the manufacture of silica aerogel. Of all the available precursor, sodium silicate or water gloss is the cheapest relatively pure salicylic acid precursor from which silica gel can be made. Where the use of hydrophilic precursor sodium silicate is safer, more effective and economical than TEOS and TMOS. The impregnation process is related to the physical interaction between the modifying material and the solid surface, either by entering the pores of the solid or by adhesive or electrostatic interactions. This process is not a suitable method for adsorption carried out in an aqueous medium, especially if soluble organic molecules are used in the dissolution process. The benefits of using the impregnation method in the synthesis of aerogel are can increase absorption power, can remove moisture from the air, increase the level of insulation purity, and have a very low thermal conductivity. So the mixing process of to get the internal insulator begin with the extraction method by extracting cellulose using 15% natrium hydroxide and 1 molar hydrochlorine because it provides a high cellulose content of 95% and free from lignin. While silica can be extracted from Bagasse with the co-precipitation method. After the silica aerogel and cellulose aerogel extracted, the two components are mixed with impregnation and dried with ambient pressure drying with sodium silicate as a precursor. Next. The conclusion. Cellulose aerogel impregnated with silica aerogel can improve the properties of the previous cellulose aerogel, and then this condition provides an advantage for the application of cellulose silica aerogel as a thermal insulator. This paper recommends making cellulose silica-based thermal insulator aerogel from Bagasse through the impregnation method followed by ambient pressure drying to produce environment-friendly thermal insulator. It is hoped that this method will produce cellulose silica aerogel with the best properties as an effort to develop new environmentally friendly material technologies. That's all from us. Thank you.